about related rates. So today we'll get into that all over again, and we'll finish up this section. So related rate has a strong link with the chain rule, because the chain rule we saw that we use with the implicit derivatives. And the example we started looking at the last time was if we have some sort of a conical device or shape and we fill it with water, the volume, the radius, and the height will change over some period of time, right? If there's a hole in the bottom of the can or the cone, there's a hole there. As water is falling out of that hole, the height of the water will changes over time, and so is the radius. I believe someone had said the radius will also change, okay? Because as you travel down the cone, the radius here is smaller than the radius here, whereas the radius here is much larger, right, in the top of the cone. So you'll see examples of how that's how we link that to the implicit derivative today. Any questions? So last class we were talking about, we said that the volume of a cone, V, is equal to pi over 3 r squared h. Okay. Now, if we differentiate this side with respect to time, okay, or let's differentiate with respect to time. Okay, so this side here becomes dv dt, and we're getting dt because it was with respect to time, and that's equal to d, the derivative of all of this quantity here, pi over 3 r squared h, but with respect to time, so we have dt on this side also. So that's what we mean by respect to time, right? We differentiate with respect to time. Now, since this here is a constant, okay, we have dv dt is equal to pi over 3, and then ddt dt of r squared h. Okay. We took the pi over 3, the constant, out. Now, if we differentiate this, we have to use the chain rule. Apply the chain rule or the product rule. So this becomes dv dt. The pi over 3 will stay on the outside. And then notice that the variable here is different, right? It's respect to t. So this becomes 2r dr dt times h, plus now the r squared, and the derivative of h is 1, and then we have dh dt. Okay, and I believe last class when we talked about this, I had left out, I think, the h or the 2, don't remember. So here we have pi over 3, 2r h dr dt plus r squared dh dt. And this is differentiation with respect to time, right? With respect to time. Any questions here? So that's where we had left off last class. Yeah. Can you guys all hear me?
Yes, Professor.
Yeah, Professor.
Yeah.
Okay. So today we'll look at an example and see if we can do the full calculation. Okay. I think I have an example. Here we have an example. The variable x and y are both differentiable function of t and are related by the equation y is equal to x squared plus 3. Find dy dt when x is equal to 1, given that dx dt is equal to 2 when x is equal to 1. So the first thing you're going to have to observe, right, and this is where you guys will have to get used to. You have an equation, y is equal to x squared plus 3. Please pay attention. Now, you will have to know there will be some sort of a hint presented to you in the problem what variable you're differentiating with. For example, above here, I differentiate with respect to time, right? In this example, I differentiate with respect to time. Now, when you read the problem, there's going to be some sort of little hint in that problem telling you what you're differentiating with respect to. And the hint in this example is find dy dt. Okay? So you have to differentiate with respect to time here again. So we will differentiate with respect to time. So what do I get if I differentiate y with respect to time? What do I get if I differentiate y with respect to time?
dy dt.
Dy dt, very good. Dy dt equal to, now I have to differentiate all of this, x squared plus 3, also with respect to time. Okay, so notice, remember as we said, right? Notice here the variables are different, right? They are different. So when you differentiate the right side, what would we get? If you differentiate x squared, you will get 2x, right? Or maybe I should write it out for you guys if you're not sure of what I'm saying. This is the same as d dt of x squared plus d dt of 3, right?
Yes.
Dy dt.
It becomes 2x dx dt.
Now, if I differentiate it now, so this side is still dy dt. If you differentiate this, the variables are different. So this becomes 2x dx dt. The variables here are different also. Okay. And you know, when you differentiate a constant in any way, it becomes
0.
0.
0. So what do we have? We have dy dt is equal to 2x dx dt. Okay, that's what we have so far. Now, if you look at the problem, it says find dy dt when x is equal to 1, given that dx dt is equal to 2. So x is 1. So we replace x is equal to 1, and dx dt will replace dx dt is 2. So if I do this, I have dy dt is equal to 2 times 1 times 2. Okay. Therefore, dy dt is now equal to 4. And there's no units here, right? So we leave out units also. So this is our final answer for that particular problem. Questions? Any questions? Nobody's saying anything. Does that mean you're totally lost, or is it really easy?
I'm good, Professor.
Good. Okay, let's look at another example. Or actually, let's look at that example. Let's look back at this one here. So in this example, what is the rate of change of the volume when the radius is 1 and the height is 2 feet? And then the follow-up question, does the rate of change of the volume depend on the values of R and H? Explain. So what you should do is read this, okay? Read this about 2 or 3 times and see what do you have to take with respect to what, okay? Remember here, guys, that the volume is equal to pi over 3 R squared H, okay? If the formula is something that you're not familiar with, generally I usually give it to you. Obviously, if it's the formula for the area of a rectangle or anything like that, you know, so that will be different, all right? So anyone can tell me what am I taking, or you know what, the first thing you should do, write down what's given, right? So if we look at this, the height of the water is changing at a rate of negative 0.2 foot per minute. So what is that? The height of the water.
H.
dH/dt, good. So given dH/dt is equal to negative 0.2 feet per minute. Okay, so that's that green part. In addition, it says the radius is changing at a rate of negative 0.1 foot per minute. So what is that? The radius is changing.
dRdt.
dRdt, yes. So dRdt is equal to negative 0.1 foot per minute. Okay. And now, what is the rate of change? So if you look at this, what is the rate of change of the volume? Rate of change of the volume. So what do we have to find?
E.
What is it?
Volume, V.
Well, what is the rate of change? Rate is not volume, is V, but
dV.
rate of
Alright,
dV. Right, the rate of change of volume is dV dt. So we want to find the rate of change of the volume. Okay, and that is dV dt. You guys really need to understand this, right? This is what this whole thing is about here. Okay, and at the same time, they said given, right? If you look at the problem, R is 1 and the height is 2. So R is equal to 1 and H is equal to 2. Somebody just woke up, now coming to class, or just left? Which one? No, just left.
There was a president who needed to restart their computer, and they said it in the group chat saying that to tell you that it needed to be restarted, and he'll be back in a couple minutes.
So we know for this particular problem that V is equal to pi over 3 R squared H, right? So dV dt is pi over 3. And then we have to do d dt of R squared H, okay? So dV dt is equal to pi over 3. We did this already, but we did plug in numbers. If you differentiate this here, you have to use the product rule. Product rule. So this becomes 2R dr dt times H plus 1, or R squared first, times 1, and then dH dt. So we have dV dt.
Professor, it's not times 1, R squared times 1.
R squared times 1, yeah, I wrote H. I thought I said 1, did I?
Yes, you did.
But I wrote H. So this becomes 2RH dr dt plus R squared dH dt. Right, this is what we did. The most tedious part in any one of these problems is to figure out what you have to find, right? And this is the key in this problem. Okay, you have to be able to read the problem and figure out what you have to find. And at the end, I'll give you, maybe I should share that with you now. Okay, so if you look at this here, let me just, okay. So here is some, nice little verbal statement that will help you with whatever we have to do.
Professor,
Yes.
are you going to talk about the airplane about this?
Talk about which one?
Cause I watched a video about in a website. There's they talking about airplane and flying to something I forgot.
Oh, that one is worked out. Look at this problem. Write down what information is given to you and what do you have to find. Okay. What is it?
dV over dt is
Wouldn't
right?
it be
And
dA over
what
dt?
rate is the total area?
Oh, the area. Oh, sorry. Yeah, bro.
Wouldn't it be
dA over
dA
dt.
dt?
Sorry, yeah, yeah. I get that, but
What
I
are
don't
we
know that's the
finding?
job.
What are we finding?
dA dt?
dA dt, very good, dA dt, okay? Well, for this particular one, I wouldn't give you a formula, right? You should know the area of a circle A is equal to what, class?
Pi r squared.
Pi r squared, yes. Yeah. Pi r squared. So now dA dt is going to be d dt of pi r squared. Obviously, the pi can comes out, so dA dt is equal to pi and then d dt of r squared. Okay. Now, since these variables are different, we have dA dt is equal to pi, right? And then we have 2r dr dt. Okay, 2r dr dt. But remember, a lot of stuff here is given to you, right? Okay. So what is given here? We want to find the ADT. So this is what we want to find. The RDT is 1 and R is 4. So the RDT is 1 and R is 4. So finally we have the ADT is equal to pi, 2 pi, then R is 4 and the RDT is 1. So the ADT is equal to 2 times 4 is 8 pi, and this is area for time, and the measurement here was in feet, so feet squared per, was it minutes or second?
Seconds.
Seconds. Feet squared per second. If you leave out the units, you'll be penalized heavily. So please make sure you write in your units, please. Any questions? Questions?
Nope.
No.
Nope.
Okay, let's look at another example. sometimes you'll have to rearrange the equations. Any questions? Questions?
No.
So let's look at the airplane problem that Yang Yang asked about.